Okay, last video for the night. So what I have here is a very, very, very fast introduction to calculus of derivatives. I'm sure I'm not going to get this 100% right according to the math teachers, but this is a physicist's view of it. So let's start off with, I'm going to go back to x's and y's. Let's make the math people happy. So I have here this first version where I have y is a function of x. X is being raised to the power of n, and then there is this constant out in front of it. So a perfect example of this would be y is equal to 4x cubed. Okay, so that's just this. And then I have another thing down here where I have y is equal to c, where c is a constant. And so, y is equal to 2. Okay, so if these are the functions, then the slope of the function is what's called the derivative. And derivative has a whole special way to show you where this comes from. So for now, this video is a bit of a trust me, I know where this is coming from. So the derivative would be written dy by dx. Okay, and then with this function here, what you do is you take the n, you bring it down, so you'll have n times k, and then you're going to have x to the power of 1 less than n. So n times k, x to the power of n minus 1. So with my example here, what I would wind up getting is my dy by dx is equal to, so I'm going to bring the 3 down, 3 by 4 is 12, 12x squared. We'll go through another couple of examples on those. So let's say I have here y is equal to 5x to the minus 3. Now you still follow the exact same procedure. dy by dx is equal to, bring down the negative 3, so we'll have negative 15 times x, and this will now be to the negative 4, because we're still taking 1 away. So there's a couple of times when this doesn't work, which we're going to skip right over, and we'll deal with them. Actually, I don't know if I'll ever deal with them. Your math teachers will deal with them. So, and then here, this trick, when y is equal to a constant, this is actually really simple. What happens is the derivative goes to 0. Simple as that. So the derivative just goes away when you take the derivative of a constant there. And then last but not least, you can actually chain together all of these. So let's say I have y is equal to 3 plus, how about a negative 2x, and then a plus a 5x to the 4th. So if I take the derivative of this, dy by dx, the 3 goes away. This x here is raised to the first power. I take that 1 and bring it down here, so that'll be 1 times the negative 2. But then the x is 1 minus 1. So this is just negative 2. And then over here, we're going to bring this 4. 4 times the 5 is 20, and x cubed. So what does this have to do with physics? Well, actually everything. Newton co-invented calculus, not happily, but he certainly did it at the same time as Leibniz, and Newton did it so that he could explain his physics. So, for instance, how about this equation? X is a function of t is equal to x naught plus v naught t plus 1/2 a t squared. So I showed you how this can get developed out of acceleration. Let me show you how this goes backwards. So velocity as a function of time is the slope of the x curve. So that means dx by dt is the same thing as velocity. So we're going to follow all of these same rules. Well, x naught, what I'm looking for here, by the way, is how x changes with t. So there's no t term here on this x naught. This is a constant. It just goes away. So this goes to 0. Now here, just like I had over here, minus 2x, I've got v naught times t. So v is a function of t. I get v naught. And then here you bring the 2 down. And the 2 and the 1/2 cancel out. And we get a t to the 2 minus 1, or just that. So this cancels out. That goes away. And so v is just v naught plus at. Well, how about acceleration? Acceleration as a function of time, at least in my class, all we've been dealing with is constant a's. Well, acceleration is dv by dt. So if we just take this, the derivative again, well, that's a constant. We know what happens to them. It disappears. And then what happens over here? Well, what happens here is there's the 1 here. So take the 1 down here, and I'm going to have t to the 1 minus 1. So it's just a. Well, this is a fancy way of saying that a, as a function of t, is a constant, which is exactly what I've always been saying happens to the accelerations in the stuff that we deal with. So this was super, super fast. Don't expect you to know anything about this. If this is only in case you wanted to see more of the math behind what it is that we're doing in AP Physics.